Unit conversions are really important in chemistry, and we'll see later on that converting from mass to the number of atoms is something that's going to be, or molecules, is something that's going to be critical in so many aspects of chemistry. But before we can get to the more advanced aspects of unit conversions, we need to kind of start at the basic ones. I will be covering the metric system in class, and we'll have some exercises in lab, and you should be reading about it. So rather than do that right now, what I want to do is jump in and solve a problem. So I've made up a problem, 3.75 meters. Meters is a metric system unit, or SI unit as we'll call it, is how many feet? Feet is the English unit of measure. What's very useful for the metric system is when you go from one unit to another, it's always a factor of 10. However, the English system is just all over the place because it has no convention. In fact, you can find many conflicting definitions, in other words, different types of the ton and how it is measured, for example. So we use the metric system. But in the real world, you will still find in the United States that we still have lots of English measurements. And being able to convert back and forth is important. And even if you're only dealing with science and you don't have the English units in that calculation, you'll find that this unit conversion process we're going to go through is a very powerful problem-solving technique. What I'm going to do is what's called dimensional analysis, easy for me to say, or factor label. Now, I learned this in high school, and once I got it, I never had to go back. I'll definitely be covering this a lot in class, but rather than give you all the formalisms of how we do this, I want to just jump in and just kind of show you how it's done, and hopefully it'll become more intuitive. So we look at our problem. We have 3.75 meters. How many feet do we have? So in this case, what we start with, what we end up with, is very obvious. Some problems it might take a little bit more to figure out, well, where do I start? But in this case, it's very obvious. Now, the way we approach this problem, or the setup, just draw a line. Now, in this line, everything above we're going to be multiplying, everything below we're going to be dividing. And this is critical, even though it seems like a small step. Put an equal sign, and then put the unit of measure of what you're looking for. And that might sound obvious, but it was not in my thought process when I was a student, especially in my non-chemistry classes like physics. You need to know what you're shooting for, right? So in this case, we know that our unit is going to be feet, because that's how I've got the problem started. What do we start with? Well, 3.75 meters. The little m is the abbreviation for meter. You can write it out or use the abbreviation, and we're going to see that we're going to be using the abbreviations a lot. Now, you draw a line here, and this is to differentiate between the next term. Another way of doing this is to put it in parentheses, because what we're going to be doing is every term on top we're going to multiply, every term on bottom we're going to divide. You may or may not have seen this in your high school classes, but really what I'm doing, it's just algebra. It's multiplying and dividing. But we're going to see what's really important in this problem-solving method, and that's keeping track of the units. So I have meters, I want feet. But I don't have a conversion directly between them. Now, obviously, if you go on the internet, you can find a direct conversion. So in this case, I'm intentionally taking a longer path than I need to. I do have a conversion between an English unit of distance, inches, and centimeters. So what I need to do is go from meters to centimeters. Now, because they're metric units, This is something I don't need to put on the board. You're going to memorize the foundation of the metric system, and I'll talk about that more later. 1 meter is 100 centimeters. So how do I put that into my dimensional analysis table? Well, I go 1 meter is 100 centimeters. And this is where you see the power of dimensional analysis. So in adjusting my camera, I somehow knocked out my microphone. So I will just give a play-by-play commentary. If you have the unit meter divided by the unit meter, they cancel out. Well, how does that work? Well, in algebra, which I'm naturally doing off screen, if you have x divided by x, it's equal to 1. A unit is equivalent to a variable in algebra. So you use the same rules. So meter divided by meter leaves us with centimeter as our unit. Well, that's not what we want. We want feet, but this is a very good start. So what we're going to have to do next is we're going to have to figure out, okay, how do I get from centimeters to feet? Notice I'm not doing any math right now. I have my calculator in my pocket. I'm not worried about 3.75 times 100 because I need to solve the problem from a unit point of view. Then I can do the math. So we have centimeters, and what we're looking for is how do I get to the English measure of length? Well, 2.54 centimeters is equal to 1 inch, or equivalent to 1 inch. So now what we're going to do is we're going to place that into our dimensional analysis table. Well, centimeters are on top, so that means the 2.54 centimeter has to go on bottom to cancel, right? So 100 centimeters is on top, and so now I'm going to put 2.54 centimeters on bottom, 1 inch on top, and that's going to cancel, getting us to the unit of inch. Obviously, we're trying to get to feet, but we're getting there. You have to be patient when you solve a problem like this because you're not doing it in one step. Here we're in step 2. Okay, so centimeters cancel. Now we have inches. This problem will actually take us 3 steps to finish. Some problems will take us 7 steps. As long as you keep systematically working through it, it'll be fine. Now, what I'm mentioning here is, what if you inverted the unit conversion that I just did? If you had 2.54 centimeters on top and 1 inch on bottom, you'd have centimeters squared divided by inch. That's a nonsensical unit. So that should tell you, well, this is wrong. If the units don't cancel as you move down your dimensional analysis table, then you've made a mistake. So now what we're going to be looking for in a moment is, well, how do I get from inches to feet? And we can clearly see 12 inches is 1 foot. So that'll be the next conversion I put in after I'm done rambling about stuff. But seriously, it's very easy to make a mistake. So meters cancel, centimeters cancel, now I'm in inches, and now we use 12 inches is equal to 1 foot. To cancel inch, the 12, we must divide by it. So the 12 inches on the bottom, inches cancel. Now I have the unit of measure, feet. That's what I want. So in a moment, I'm going to dramatically pull out my calculator. There it is. And do the math. You don't need your calculator until you've actually solved the problem. And again, that seems counterintuitive. I'm sure many of you have done problems where you do a small calculation, get a number, take that, do another calculation, get another number, and just rinse and repeat. You could do that with this problem, but the probability of making a mistake goes up. Because if you don't keep track of the units, how do you know what the number means? And in this particular setup, I know I have the correct answer because the units cancel. Meters cancel, centimeters cancel, inches cancel, and I'm left with feet. So now I just need to take 3.75, multiply it by 100, divide it by 2.54, divide it by 12. Obviously, you could multiply it and divide it by the ones, but that's not going to change the answer. So again, you can use a little common sense for your algebra. 1 times something is the same thing, 1 divided by something is the same thing. So in a moment,
I will have a numerical answer. Another thing to think about is the physicality of it. 1 meter is about 3 feet. It's not exact, but it's close to it. So we get 12.3 feet. That physically makes sense based on the type of problem that we're doing. If I wrote down that I had 1.2 feet or 123 feet, well, that's off by a unit of 10, right? So that would say, wait a minute, I made a mistake in one of my unit conversions, probably the meter to centimeter, if it's a unit of 10. So with these kind of problems, you have the math component of it, but you should also, when it's appropriate, think in terms of, well, what does this physically mean? Am I talking about something that's as big as a softball, or am I talking about something as big as an iceberg? And in many cases, you can just look at it and go, okay, that number looks reasonable, and so I most likely did the math correct. With this particular problem, really the only thing after you have your dimensional analysis table set up, the only thing you can really make a mistake on is putting the numbers into your calculator, assuming all your conversions are correct.